Hey there, it's me, Miss B, and in this video we're looking at the Unit 3, Lesson 13 Cumulative Practice Problems for Illustrative Math Geometry. So, question 1, we have a right triangle, ABC. So that is this whole triangle, ABC. They're saying it's a right triangle, so we have our right angle right here at C. An altitude CD is drawn to its hypotenuse, so that's saying that this is the hypotenuse. It's going from this vertex to the hypotenuse. We want to select all triangles, which must be similar to triangle ABC. So ABC being this direction. So we need to make sure that order matters. And their hint is that you may want to draw out the triangles separately and label the corresponding congruent parts. So we can do that. I will draw a little sketch here of my biggest triangle. I'm going to use that for my right triangle, and we will call this one, this is going to be ABC. But I have to make sure that I have things lining up correctly. So C is at the right angle, and then I have my shorter side has A, and my longer side has B. And then I'm actually just gonna copy over this triangle here as my small one and move this over, and I can use those letters exactly, which are A, D, and C, because the short side, the 90-degree angle, and the other end of the longer part here is at C. And so now I then just have my middle-sized triangle, which is this one right here. So this one we can actually take, and to get it in the right direction, I just need to rotate it 90 degrees upwards like this. So that was my medium-sized one. And then that would be D had the right angle, B was at the pointier end, and C was here. So that means if we're asking what is similar to ABC, we're going to go in that same order around these. ABC is going to be similar to ACD. So ACD. And then here, that's going to be CBD. So CBD right here. And it's going to be congruent to itself, so we can even say, or it's going to be similar to itself, right? So we can say ABC is similar to ABC, but those are the three similar triangles, ABC, ACD, and CBD. For question 2, we have a right triangle ABC with altitude CD, and length H is drawn to the hypotenuse. We also know that AD is 12 and DB is 3. What is the value of H? And show all of your work. So we have H here, and we have 12, and we have 3. We can use the geometric mean to do this question here. We can say that 12 over H is equal to H over 3. Because the altitude, this one right here, is the geometric mean between the two separate pieces of the hypotenuse. And being the geometric mean means that we can set it up in a proportion like this, and it will be diagonal from itself. So now all we have to do is solve. So we'll have H squared equals 12 times 3, which is 36. That means square rooting both sides, H is going to be 6. Okay. Now for question 3, we have triangle ABC, which is very specifically not a right triangle. Altitude CD is drawn to side AB, and the length of AB is C. Which of the following statements must be true? So let's zoom in on our diagram here a little bit so we can actually see this. Here's H. That does make a right angle, but the triangle itself is not a right triangle. It just has a 75-degree angle here. This whole hypotenuse, well, it would be a hypotenuse if it was a right triangle, but it's not, so it's not a hypotenuse. This whole side length is C. and it has smaller portions. So let's look at what we actually have here. They are saying the measure of ACB is the same as measure of angle B. Well, B is here, and ACB is there. Not necessarily true. Let's look at this one. B squared equals C squared plus A squared. B, C, and A, well, that's also not necessarily going to be true. That would be perhaps a relationship if this was a right triangle, but definitely not true on that one. Triangle ADC, sorry, this one was also incorrect. ADC is similar to ACB. So where is ADC? And they're saying it's similar to ACB. No, because that's saying that this matches up here and those are not right angles. So it is not this one either. There is actually only one here that is accurate, and that is the area statement right here. That the area of triangle ABC is 1/2 H times C. And that is because C is considered our base and H is going to be our height, and the area of a triangle is 1/2 the base times the height. So that's it for the first 3 questions. We're going to move to the back, and then we have 4 more. So quadrilateral ABCD is similar to A prime, B prime, C prime, D prime. We are going to write 2 equations that could be used to solve for missing links. We're just going to set up some proportions here because they're not telling us that anything is missing. So this is kind of a roundabout way of them saying like, hey, please write out some stuff you can find here. So I could say that AB over A prime B prime is equal to, and then I just have to be consistent. Since I don't have an image, I'm just being consistent. So I could use CD, and by consistent, I mean using my regular one at the top, I then have to use the prime version of it, C prime D prime, at the bottom. I can also, so I like to think of the sides and their relationships and going in different directions. So like where is the original side and where is its prime version? We can also do that left to right. So I could have something like, I'll just use different letters here. So I'll use B, C, and then if I also write a proportion here, I could have B prime, C prime here, and that would work. So because I have my original and now my prime version, I just have to make sure I follow the same pattern, original and then prime version, going in that same direction. So that's what I mean about being consistent. If I took it the other direction, that would be wrong. Yeah. So let's see. Let's say like D A and then D prime A prime. So something like that. Really, your answer is any 2 accurate. Accurate has 2 C's in it. Accurate proportions. So you don't have to use the ones that I used specifically. I just wanted to demonstrate like how we can have the different types of them. And both of these would work if we took the reciprocal of each side. So those would be the same as well. That brings us to question 5. We have segment A prime B prime right here, which is parallel to AB. So I have my 2 parallel pieces. We want to show all of our work to solve the following. So those are my 2 parallel ones. They want to know what is the length of segment A prime to A and B prime to B. Okay. So we have a couple ways of doing this. I normally like to think of my parallels as like parallel to the floor. So if I was looking at this on paper, I might spin my paper a little bit so that I have them looking that way. But either way, this is digital, so even if I spun my tablet, you wouldn't be able to tell. Now let's actually figure out what proportions we can use here, because we are looking to find, I'm gonna just call them X and then Y, just so that I have some variable names here. I'm looking to find X and Y. So the only proportion I have to start with is going to be 8 and 20. But that's not going to help me just get X. So I can't just compare X to 12, even though X has 12 on the same side with it. The relationship I'm going to write out here is going to be small triangle part over big triangle part. So for the small triangle, I can do 8 over 20. And so that comes from the parallel pieces, 8 over 20. But I can't then say 12 over X, because X is not the side of a triangle. That's just part of it. I actually have to use this whole piece here. So I'm going to use that as 12 plus X. And that is the entire distance. So I can compare that here. I can say, okay, 8 over 20, that should be the same as 12, which is from my small triangle, and then 12 plus X. Now, our cross multiplication still works the same way, but we're going to treat 12 plus X like it is inside parentheses, and that would get multiplied with 8 distributed through. So let's do a little bit of calculations here. 20 times 12 is 240. So we are going to have 8 times 12 plus X equal to 240. Now I'm going to distribute that 8. I like to always write it there first before showing my work, but if you're comfortable just distributing, you can do that. So that means 96 here, and then plus 8x equals 240. From there, we only have 2 steps. We're going to subtract 96 from both sides, and that leaves us with 8x equals 240 minus 96 is 144. And then we're going to divide both sides by 8. When we divide that by 8, we would get x equals 18, or basically a prime a is 18, since I gave it a variable as a name. Oops, I just scrolled down. I was like, I thought I was scrolling left to right, and then it snapped to a different part of my page. That was weird. For a second, I thought it erased everything because I saw this question here, blank. Okay, so that's how we would do this. That part, we're going to do the same thing, but in order to find B prime B. So the length of segment B prime B, we're going to do the same idea. We're going to compare it to 8 and 20, but now we're using 6 and Y. So I'm actually going to change this Y to be blue, just so that I am color coding everything, and you can see that I am also going to express this one as 6 plus Y in a quantity there. So still going to do small triangle over my big triangle portion. So 8 over 20, and we're going to compare that to 6 from the small triangle, and then 6 plus Y for our variable. So 20 times 6 is going to give us 120. So we'll have 8 times 6 plus Y. I'm just going to leave that equals 120. 6 times 8 is going to be 48 plus 8y equals 120. We're going to take that 120, subtract 48. We'll get that 8y is 72. And when you divide that by 8, you get that y equals 9. So we know that B prime B equals 9. if I ever assign a variable to a specific length and they're asking for that length, I always make sure that I name it as the segment when I'm trying to show my answer. Then that way no one has to go digging for like what I decided to label my variable as. Okay, that brings us to question 6. Lines BC and DE are both vertical. I know that if they are both vertical, that means they're going to be parallel to each other. Okay, so what is the length of AD if they have things labeled here? So AD is the entire distance across the bottom here. Now this one, 2 and 5 are from the small triangle and the large triangle respectively as these sides here. And the nice thing is they are not just asking for a chunk. Since they're asking for the whole thing, I don't have to do any of this like 3 plus x stuff that I did on the previous question. So I'm going to say, and even in this one, I'm just going to compare the small triangle to itself, like the bottom to the side, and then bottom to the side here. So get my marker. All right, I'm going to say 3 over 2 is equal to, and I don't know this distance, I'll just call it AD over 5. Let me cross multiply. 2 times AD is going to be the same as 3 times 5, which is 15. So when we divide both of those by 2, AD is 7.5. So we're going to select option C because it does say to show our work. So we are going to leave all that work there as evidence that we knew what we were doing and didn't just randomly pick an answer. So that brings us to our last question here, which is triangle DEF is formed by connecting the midpoints of sides triangle ABC. So midpoint, that sounds like an important word to me. I'm going to highlight that just so I don't forget that I'm using midpoints. We want to select all true statements. Okay. So they're saying, you know what? Some of these ones with the lengths might be easiest to determine first, so I can check those. They're saying BC, this distance is 8. We would compare that to one that it's parallel to, which here is 4. And if these are midpoints, then yes, it is going to be double that amount. So that one is going to be true. That one is going to be true. BC as 6. Let's double check. We're going to see which one that is parallel to. Oh, well, it's just the same segment. So no, it's not 6. We have to check it with the one it's parallel to, and that's the one it's times 2. Okay, so let's check the rest here. Triangle BDE is congruent to FCE. I'm going to go with no on that one because the order matters. BDE would be congruent to EFC. So we're going to say no to this one because the order is incorrect. They're then saying BDE is going to be congruent to FDA. FDA. Again, the order is incorrect here. BDE is just translated down, so it should be DAF if it's going to be congruent to that. And then we have BD is congruent to FE. So BD is congruent to FE. This is going to be true because FE here is going to be congruent to this piece. And we know that since it's the midpoint, it's been cut in half. So the answers here should be C and D. And that is it for this assignment. So thank you for sticking with me on this. This has been Unit 3, Lesson 13, Cumulative Practice Problems for Illustrative Math Geometry.